This is part 2 of the Unit 4 review packet. We'll be covering pages 3 and 4. Starting with number 16, which corner of the triangular plot of land forms the largest angle? Justify your response. We know from the previous problems that the largest angle and the largest side go together. Here our largest side is 62, which means the angle opposite that would be B. So my answer would be angle B. Number 17. In triangle DEF, DE is 12 inches, EF is 6 inches, and DF is 8. List the angles in order from smallest to largest. Definitely going to draw a picture. So I'm going to label my triangle DEF. And it tells us that DE is 12 inches, EF is 6, and DF is 8. We're looking for smallest to largest. The smallest side is 6. That's across from angle D, so we know the smallest angle must be angle D. The next smallest side is this one at 8. Well, that's across from angle E. Angle E must be my next smallest, followed by the largest angle, angle F. Number 11, skill 11. Use isosceles and equilateral triangle rules to complete the following congruency statements. Justify each response with a theorem. So this one says AC is congruent to AD is congruent to. AC is here, AD is at the top. This triangle has 3 angles that are marked congruent, which means that all 3 of these sides have to be marked congruent. So we know that AC, AD, and then the last one, DC, have to be congruent. In this one, because we use the angles to determine that the sides were congruent, and we use an equilateral triangle, that's the converse of the equilateral triangle theorem. Again, it's equilateral triangle theorem because we were working with an equilateral triangle, and it's a converse because we started with the angles and then moved to the sides. Number 19. Angle ACB would be here. It's congruent to angle B, which is congruent to. We've marked these 2 angles congruent, so it seems pretty obvious that the last angle would be the top one, and that would be BAC. This time, we used the fact that there was an equilateral triangle. All 3 of the sides were marked congruent in order to mark that third angle congruent. This is the regular version of the equilateral triangle theorem. If you start with sides, it's the regular version. If you start with the angles and use it for the sides, that's a converse. The same will be true on this. For number 20, AB is congruent to. If we look at segment AB, AB is in this triangle ABD. These 2 angles at the bottom of this triangle are marked congruent. Because these 2 angles are marked congruent, it means that these 2 sides have to be congruent as well. So that means BD must be the side they're talking about. Because I started with the angles and moved to the sides, that's going to be the converse version, and I was using a property of an isosceles triangle. So this would be converse of isosceles triangle theorem. Angle C is congruent to. We already have this marked congruent based on the results of number 20. C must be congruent to D. If these 2 sides are congruent, then the base angles that made them have to be congruent as well. But we can't call this angle D because there's multiple angles that correspond to this vertice. We'll have to call it BDC. For our justification, because we knew the sides were congruent to start with, that would be the regular version of this theorem. So we would say isosceles triangle theorem. 22. Use isosceles and equilateral triangle rules to solve for the unknown variables. This triangle is equilateral. All 3 of its sides are congruent, which means that all 3 of the angles are congruent. In an equilateral triangle, every angle has to be 60 degrees because every triangle adds up to 180, and if you split that 3 ways, that means each one is 60. Well, that gives me the equation 2x plus 10 has to equal 60 because that 2x plus 10 refers to the angle. Subtract 10, divide by 2. Half of 50 would be 25. 23. This is also an equilateral triangle. The three angles are congruent, which means the three sides must also be congruent. So I can set any of these sides equal to any other one. Now, it's not particularly helpful if I set 2x equal to 3y, because that gives me an equation with two variables in it, but I can set 2x equal to 24 and 3y also equal to 24. To solve for x here, divide by 2, and that's going to give me 12. To solve for y, divide by 3, and that'll give me 8. For 24. Looking at this, we know that these two angles have to be congruent. This is an isosceles triangle because these sides are marked congruent, which means the angles that are opposite those sides have to be equal. Now, z and 135 form a linear pair, which means they have to add up to 180. Subtract that 135, and that's going to get me 45. Now, in an isosceles triangle, these two base angles are congruent, so if z is 45, that means x has to be 45 as well. Which leaves us with y. Every triangle has to add up to 180 degrees, so that means that 45 plus whatever y is has to equal 180. Combine my two like terms. Subtract that 90 on both sides, and that gets us our value of y. (25). Solve for the measure of x. If I look at the little triangle, these two sides are marked congruent, which means the base angles opposite them have to be congruent as well, which means this angle has to be 50. Now, in every triangle, we know that all three of the angles have to add up to 180. So if I set 50 plus, I don't know what this angle is. I'm not going to call it x because there's already an x. What if I call it y? That means that all three of those have to add to 180. Well, 50 and 50 would be 100. And if I subtract that 100 off on both sides, that gives me 80. So this angle right there has to be 80. This angle of 80 is vertical to x, which means they have to be the same. So if this angle is 80, then that means x has to be 80 as well. 26. In the top triangle, we have an isosceles, and in the bottom as well. These two angles have to be congruent. So if this one's 45, it means this one has to be 45 as well. That gets me the equation, because all triangles equal to 180, 45 plus x equals 180. Now, I've actually solved something identical to this over here. 45 plus y equals 180. So you are welcome to solve this. However, because I've already got the work, I'm just going to take a shortcut and say that means that x has to be 90. In the bottom triangle, again, this is isosceles, which means if this is y, this one has to be y as well. So that gets me y plus 120 equals 180. Now, if I subtract that 120 off and combine my two y's, that'll get me 2y equals 60, divide by 2, and that gets me y equals 30. Finally, 27. These two angles have to be congruent. This is an isosceles triangle, which means the opposite angles are the same. That lets me write an equation, n plus n, because if this one is n, the other one has to be n as well, plus 90 equals 180. So I'll subtract that 90, combine my two n's, and that will get me 2n equals 90. Divide by 2, half of 90 would be 45. Next, we take a look at the triangle up here. This congruence mark is the same as this one. I know that n is 45, so if n is 45, it means that angle has to be 45 as well. And because this is an isosceles triangle, these two angles have to be equal. So that gives me 45 plus m equals 180. We'll just call that 2m. To get m by itself, subtract 45 on both sides. 180 minus 45 would be 135. And last, divide by 2. And that would give us m equals 135 over 2. For 28 and 29, circle all groups of sides that could form a triangle. In order to form a triangle, the two smallest have to add to be more than the third side. For A, the two smallest are 2 and 6, which make 8. 8 is not larger than the third side of 8. A will not work. Here, the two smallest would be 3 and 4, which makes 7. 7 is bigger than that third side, so B would form a triangle. In C, my two smallest sides are 1 and 5, which make 6. 6 is not larger than the third side of 7. In D, the two smallest would be a 2 and a 2. 2 and 2 is 4, which is larger than the third side. That one will work. And finally, E, the two smallest are 5 and 12, which makes 17. 17 is bigger than 13. We can use that to make a triangle. 29. Which of the following cannot be the side lengths of a triangle? So, two smallest must be bigger than largest. 1 and 6 makes 7. 7 is not bigger than 7. These lengths could not form a triangle. The question's asking us to find the ones that can't. A is my choice. 30. Can a triangle have sides with the given lengths? Justify each response. You can write down the justification. I'll just talk about it. Here, the two smallest would be 6 and 8, which makes 14. 14 is bigger than 13. Yes, they can. B. 9 and 3 are my two smallest. Together they make 12. 12 is equal to 12, not greater than. So we would not be able to form a triangle for these. Finally, here the two smallest are 5 and 4, which make 9. The third side is bigger than the other two combined. This would be no. 31. Two sides of a triangle have lengths 12 and 11. The third side must be greater than what and less than what? To find the minimum value, we just subtract the two sides of the triangle. And to find the maximum value of the third side, we add them together. So for the minimum, 12 minus 11 would be 1. And for the maximum, 12 plus 11 would be 23. The length of the third side must be greater than 1 and less than 23. Greater than this because that's the smallest, and less than this because that's the maximum. Two sides of a triangle are 7 inches and 9 inches. What is the range of possible lengths for the third side? Justify your response. 9 minus 7 would be 2. 9 plus 7, 16. This is asking us to write it as a range, so we could say 2 is less than x is less than 16. 33. Which could be the distance? Here they're giving us two sides and asking which of these could possibly be the third side. If we figure out the range of values for the third side, we could figure out which one of these falls into that range. So our minimum distance would be 325 minus 250, which is 125, and our maximum would be 325 plus 250. That'd be what, 575. So we know that our value has to be bigger than 125 and less than 575. Now, this 575 is a strict maximum. You are not allowed to be equal to it. It has to be less than that. So 575 itself can't be the answer because it has to be less than 575. 75 is too small. Our minimum was 125. 600 is too big because it's actually even past our maximum, so the only choice here would be B. 34. Using our knowledge of the Hinge theorem, given the triangles below, compare AC and XZ if XY equals AB, ZY equals BC, and the measure of XYZ equals 32, XYZ is 32, and ABC is 45. The Hinge theorem just says that if you meet the conditions of two pairs of congruent sides, then the one with the bigger included angle will have a bigger third side. In these two triangles, 45 is the bigger included angle, which means that AC has to be the bigger side. Let's say AC is greater than XZ. 35. Which of the following statements is true? Comparing the third side means we're going to be looking at AC and RT. Here we have an angle of 98. Here we have an angle of 90. 98 is bigger than 90, so AC must be bigger than RT. So AC greater than RT.